true that it actually does both.
This is a good turnout for a Friday afternoon. After Halloween. Great, yeah.
I didn't realize I had to fill in fields like that. Well, I think it's right there. This is just the the video audio recording.
Sure. IRB approved. Probably not.
The lawyers, you know.
Do I need to? You got it.
And then initial.
Okay.
So there's two different options. There's the internal and the external. If you initial both, it basically means we can put it on the web page.
Very good.
You can also revoke it at any time.
Excellent.
If you decide you don't want to post it.
We'll shred it.
So after the presentation, when I bomb it.
And all set with audio, video, everything good?
We're good over here.
Are we at time?
I think so.
Did they mic you?
Yes.
You're on the ball.
Yep. Oh yeah, they know what they're doing.
All right, so we'll go ahead and get started. Thank you all for coming on a Friday afternoon. It's my pleasure to introduce Dr. Karen Hollebrands here from NC State. She works in the STEM education department over there as a mathematics educator. She's also their graduate program director and the current editor of Mathematics Teacher Educator.
Journal, yeah.
Pleasure to have you.
Great, thank you. Thank you for inviting me here to talk. It's a pleasure. I've never been to Boone before. It's beautiful. I enjoyed my drive in. It's also a little cold. It was 82 degrees yesterday in Raleigh, which is warmer than normal, but I wasn't expecting 30s here, but I'm glad I brought my coat. So anyway, I'm going to talk to you today about a study that we recently completed looking at early career teachers' uses of technology. One of the pieces of my research that I focus on is how we prepare teachers to use technology. And then we wanted to see what they were actually doing in the classrooms. And so I'm going to share some of that work, and then I'm going to give a preview of some of the other work that we've been doing since the completion of the study. So if you want to read more, you can go to the Computers in Education Journal. It was published in 2018 with my colleagues Allison McCullough, who's at UNC Charlotte, Holly Lindley, who works with me at NC State, and two doctoral students, Taylor Harrison and Asla Mutlu, were working on that project as well. So before I start and talk about the study, I just have a few opening questions to ask. So if you were asked, what % of teachers do you think have access to computers? And we're talking about high school teachers. What percent? 90, pretty high, 94. The teachers or their students? The teachers and students. That's a good question. Very good question. Teachers. Teachers have access to computers for students. For students. Not just a computer with a single station on her desk, but one that can be shared with students, so that students have access. Still pretty high. Still pretty high. What about why do you think they choose to use technology? What might? Okay, so visualization, better understand concepts. Why else might a teacher want to use technology? Yeah, it's important for preparing them. Excellent. You're going to give my talk away. And then what are some types of technology you would expect teachers are using, high school math teachers? TI, yeah, TI has been around forever, right? It's not going away. It's required on exams. So it's definitely the graphing calculator. Desmos, okay. So that assumes maybe on phones. Yeah, but maybe they're using it on their telephones or on tablets or computers, right? So it goes across platforms. So Desmos is a good candidate.
Their number is in diagnostic or prescriptive.
Yeah.
IXL,
Yeah.
some things like that.
Yeah, so maybe some tutoring type programs to help develop skills for students. Good. And what are some things that teachers might think about when they're deciding whether to use technology?
Students have access outside of.
Yeah, so if there's something you want to do in class, will they have the same access to it outside of class? Yeah, these are all great. So these are things that we thought about, but we weren't sure. And so we wanted to find out more about what happens when they leave our NC State, they go out into the schools, and we prepare them to use technology. What do they actually do? So that was sort of the premise of our study. So we know, as you already talked about, it's really important to prepare teachers to teach mathematics with technology. And we also know that if we only focus on a single course where they're learning the specifics of how to use that technology, that's not sufficient. They need to sort of experience what it's like to use technology to learn mathematics in order to be able to use it themselves with students in the classrooms. And so we developed at NC State, beginning in 2005, these modules that focus on how we can integrally develop teachers' knowledge of mathematics, technology, and pedagogy. We started with a data analysis and probability unit, then we created a geometry unit, and finally an algebra unit. And the way that we structured our modules is we typically started with a mathematics problem or statistics problem that they had to solve using technology. And then we would have them sort of step back and put on the hat of a teacher and think about what are the implications for the use of the technology in solving this problem that might relate to teaching in a high school classroom. And so here's an example of a type of problem that we include in the module. So this, if you're not familiar with, is called the partitioning lay-in problem. I love it. It's from Key Curriculum Press. I didn't create it. But essentially, you're given this quadrilateral, and you want to split it so that the two brothers have equal area on this island. And so they want to figure out what's a good way to divide it. And then we talk about issues like, well, if this is an island, you want to make sure that you have good oceanfront access, right? And you want to make sure you don't just have pieces on one side and the other side. That wouldn't be really very practical, but they should be contiguous. And so we talk about the problem and how they can solve it. And what's nice with this problem, there's at least 7 different solutions and different levels of generalization that students come up with, which are really nice. And then we talk about how it connects to teaching. So those are the different pieces that we have in the materials that they are using. So as I mentioned, we had 3 modules. And each module we address technology, mathematics, and pedagogy. The technology that we're using with our teachers includes Desmos, as well as TI, graphing calculators. Those will still be around. But with the statistics, we're bringing in CodeApp. We started with Tinkerplots and Fathoms back in 2005. We're using the Geometer Sketchpad, but now moving to GeoGebra, and I'm doing some work with Web Sketchpad, which is really cool. But that's the technology we're using. This is some of the mathematics that we focus on, and then this is the pedagogical skills that we want them to develop. So as I mentioned, the purpose of our study was to investigate how early career teachers who go through a program that has a heavy emphasis on the use of technology, what do they actually do when they go into the classroom? And so we examined the literature around teachers' uses of technology, and we sort of separated that literature into 3 different categories. One was about the factors that influence technology use. The other was how technology is positioned. And then the third one's about how to prepare teachers. So in terms of the factors that influence technology use, the literature tells us that there's external barriers that influence whether or not a teacher will use it. So availability is certainly a factor. The support that they receive from their administrators at the school is a factor, and whether or not they have the professional development. You all know that if you're told to use a particular software program but nobody tells you how to use it, you probably won't, right? So PD is really important as well. There's also internal barriers, right? So if you're given a particular tool but you're not really convinced it's going to be helpful, then that might be a reason why you choose not to use it. Or if you have a belief that maybe technology should only be used for drill and practice. That could be a belief that also influences how it's used. So what we do know, so here's your number, 95% of math teachers have at least one computer, right? So that was the question about whether they have access. So the question really was about teachers. Yeah, so teachers, 95% have at least one. But if we include access to computers that they can bring in the classroom, then it increases to 99%. So most teachers, if they want to use technology, will find it. If it's not in their classroom, they can bring it in from the media center on a cart, that sort of thing. So it seems like the external barriers, like access, might be going away, but the internal barriers might still exist. We also know that just bringing in technology isn't going to be effective. It's really about the way and the role that that technology plays in the classroom that's more important. So there's a lot of research that will show that if you're only using technology for practice and skills, that's not going to help develop students' conceptual understanding. So it's really important to think about the ways in which technology is used, not just whether or not it's used. We also know that from AMTE, they have standards that point to the importance of making sure that teachers are well prepared to use technology. All right, so our specific research questions are focused on why teachers choose to use technology, what they choose to use, and what are some of the factors. So those were our three specific questions that we examined. We interviewed 21 teachers from 19 different schools. Most of them were our early career with having less than 5 years experience. We had 2 that had a little bit more experience with 7 and 9 years. And all of them had received, had gone through a program that had used the PTMT materials. We had semi-structured interviews, so the protocol that we created to do the interviews was informed by the literature. So we knew some of the factors that we had identified in literature were things that we were going to ask about. But we also wanted more open questions so that if things came up that we could pursue that as well. We transcribed our interviews, and then we used Atlas TI as a way of analyzing it. And we had our codes that were partly coming from the literature and the other part from what they were saying. So this is just an example of what the Atlas TI looks like. And so what we found when we were analyzing the data is there's sort of this process that teachers go through when deciding to use technology. First they ask, should I use it? Right? So they might think about what's the mathematical goal or statistical goal, and they want to decide, is this an appropriate thing to use technology for? Then they might say, okay, yeah, maybe I should use technology for this. Now what type should I use? And then finally they'll ask themselves, so what else do I need to think about? So that was kind of their typical thought process. In terms of our questions, we had the question about why they use technology. And as you mentioned, to develop conceptual understanding was something that was mentioned. And also to provide opportunities for practice was something else that we saw that they just talked about. When it came to which technologies, we sort of grouped them into these 3 broad categories. There were sort of the mathematical tools, like your old TI, Desmos, that sort of thing. There was collaboration tools, which kind of surprised. I guess we should have known, but we weren't thinking about that. But Google Documents, things that allow them to work collaboratively together. And then there's assessment tools like Kahoot and all those fun things that they learn about as well. Some of the factors that they consider, they look at what are the interactive features of this tool that I might be able to capitalize when teaching a particular topic. How is it going to support my instructional goals? Do I have access, and is it compatible with the many devices that students are now bringing into class? And how easy is it? The other thing, yeah, we'll get to that. All right, so reasons why teachers use technology. I'm going to let our participants tell you some of the reasons why they use technology. So if the video works, you'll hear from some of our participants. So let me, here we go. Oh, so I need to go to a different screen. Do I have to escape out of PowerPoint?
So
yeah.
you can easily give a discovery activity where the students are trying to figure out what's a shape dilated, what is it the factor of, for instance, in a geometry lesson, and they can manually do that by hand. Is it more productive for them to take that time, or is it going to be easier for them to
Oops. Oh,
to
there we
focus
go.
less on doing the actual constructions in the drawing with some sort of technology where they can just type in or change a slide and it will actually do the dilation or the transformation itself. And with the technology, they were able to run through different values quite fast and efficiently and actually visually see it happening before their eyes versus looking at different still pictures.
And then when I can ask a simple question, what does that mean? And it can be a little bit, that's where the struggle sets in for some of those kids. And that's where I think like maybe some of the applets where all of a sudden kids can see, well, what do you mean by the normal computer? Like it's a coin thing. Some of those tools that we have access to now, you can have 1,000 examples at once.
So the graphing calculator definitely helps bridge the gap between what the students allowing the students to access the curriculum if they do not have the prior knowledge. For example, with the integers, adding, subtracting, multiplying, dividing integers. If you are unable to do those, it's going to be very unlikely that you can solve a multi-step equation. However, if you can use the calculator to get those answers and be able to move forward with the problem instead of getting stuck on something, as simple as adding two negative numbers.
One of the things is I want to make sure that whatever I'm using is going to actually get the point across from the lesson. I don't want it to be some kind of activity that's just busy work. Hey, check this out, this is pretty cool. I want it to be some kind of lesson or activity that they are going to be able to discover something or put to use something that they have learned in a different way. Learning how to factor and finding zeros is very different from looking at graphs and determining could this image be the graph of this particular quadrat, for instance.
Will it be beneficial? Is it just using technology just to use it, to say I used it because it looks good, or is it actually going to promote deeper thinking and further understanding? That's what I try to look for versus just using it just to use it.
I guess it depends on the standard that I'm trying to achieve first and foremost, I guess, and whether I think technology is the easiest way to, for the most efficient way and for the most beneficial way to achieve that goal. So like something like rational functions, for example, sliders are a great way for them to be able to see, oh, so when I change these values of the denominator when it's factored, the vertical asymptotes move. Or even if they don't know what the word vertical asymptote is yet, there's these vertical lines on the screen. As opposed to just being told, like, to find vertical asymptotes, you have to find the zeros of the denominator.
Absolutely. So Kahoot, I like to use it as a review game, and so it's just a time for the students to really show what they know, but it's also in a fun environment, so they kind of are tricked into enjoying doing practice problems, and so it's a nice option instead of just a worksheet. And so I think it just gives them time to quickly put their knowledge to the test to see what they know and what they don't. And it's nice for me as a teacher because I immediately get the results.
I usually use Kahoot near the end of the lesson, never for anything new, but as kind of like review. And big thing is it gets them all engaged. Even the kids that are typically in the back that don't want to avoid, participating, they'll get into it. That's also nice for quick feedback, especially depending on what kind of assignment I put on the Google Classroom, but I can get real quick feedback and talk about what we need to keep going on and look over, clear it up. So I love the quick feedback of the technology.
Okay. So those are some of the reasons that the teachers talked about why they choose to use technology. We also asked them the types of technology that they were using, and as you anticipated, we found that the types that they talked about were mathematical action tools like the graphing calculator. But what's funny though is that graphing calculator wasn't the first one they mentioned. So they would talk about, oh, I have these computers and I have this different software, but they never talked about graphing calculators until we prompted. And so I wondered, because they've been around so long, maybe they just assume it, right? There's certain things that you no longer think about as technology, just because they've just always been there. They also talked about dynamic mathematical environments. Some talked about tinker plots, different applets, GeoGebra, that sort of thing. They talked about using collaboration tools to get students to be able to work together to solve a problem collaboratively. And then the different sorts of assessment tools. So there was a lot that they mentioned there. And the ability for teachers to get feedback on what students know and don't know, they found to be very helpful. So we also looked at the factors that they consider when using technology. So I have this is my last video of students are here, or participants here, talking about that. So let's see, factors. There we go. Should be able to get bigger. So just like we mentioned, ease of use is important.
Well, probably two big things. One, is it usable? Is it kind of intuitive for kids? Because, I mean, anybody that's in a classroom will tell you, you have limited time anyway. So if you have to spend a class period or two telling kids how to use the technology, it's kind of frustrating before you can even get into it. So it's something that's usable.
I play with the technology too, just to see if it's user friendly. I don't like to use something if I'm going to have to spend time teaching them how to use it. I want it to be pretty easy for them to figure out how to use, so I don't have to spend as much time. I can spend more time on the lesson versus teaching them how to use the technology.
And also just, I guess, ease of use with the different program. If you're going to use technology, I don't think you want the technology to be burdensome. You want the technology to be easy to maneuver so that the burdensome part is the math, right? You don't want to make them dislike something because they can't operate it properly.
And then also just, is it truly applicable to what I'm supposed to be teaching them, to the curriculum, or is it something that just looks fun and I'm trying to make it work? Because if I'm just trying to make it work, then it's not worth our time, even if it is fun, and they will learn something. They may not learn exactly what we need.
Some of the teachers, it's really depends on what you're teaching. Can it show off the concept, so to speak, the whole concept, and not just one little thing, and then you have to talk about it. One little thing, and then you have to talk about it.
I mean, usually if I'm deciding whether or not to use something, it's a big decision. Is it free? If it's free, I'm much more likely to use it.
And so, like, I want something that can format to an iPad or a computer or their phone. And so, is it compatible with an iPhone and Android? Like, can it, does it require students to log in? Like, I don't like when they have to log in because it's an extra barrier. Is it something I can get? Is it something they can download and work off the Wi-Fi, or they have to be on it? So some of those logistical needs.
One thing. Another thing is accessibility, and how easy can I use this technology with what I have in my classroom. We have a class set of 10 laptops now. But if I want to use an app that has to already be downloaded on all of those laptops with a certain username, for it to actually register on that, then that doesn't help me whatsoever. If it's something that I can just say.
I would say one where students are very hands-on in manipulating things and noticing differences.
So one of the features would be, some of the tasks we give the students being able to type in an answer and get feedback if it's correct or if it's incorrect, so that they are not able to move forward with a lesson unless they are getting the right answer.
Instantaneous is good. I like that. Being able to like drag things, and so not really like, hey, go to this and then go to that, and then like intuitive. Like I appreciate intuitive technology. But yeah, the instantaneous part is kind of important to me, because like if a kid types in a function in Desmos, it immediately appears, and they can, if they have sliders like that, is something that they can do, and it's like instantaneously with the graph, so it's nice.
Okay. So a lot of the things that you might anticipate students would be saying about use of technology. So back to our sort of the cycle that they go through. Should I use technology? This is some of the things that they said. Will it provide opportunity to build understanding or to practice skills? What type of technology might I use? And what else do I need to think about? So that's sort of how the process that they go through in making a decision sort of aligns with the different themes that we saw in the responses that they had to our questions. So all the teachers that we interviewed seemed to have access to technology, so that didn't seem to be a problem. However, what we did notice is that there was a variety of different technologies that teachers were using. So they kind of have a suite of tools. Some have iPads and laptops and phones and tablets, and so whatever they're using has to go across these multiple platforms, which wasn't something that we had anticipated hearing. There was also different technologies that teachers were often using within a single lesson. So like they might start their lesson with a quick poll everywhere and then go to CodeApp and then go to Google Documents, and then they go to a Kahoot at the end. And so they're using like 5 different technologies all in the same lesson. So we did go out and we observed some of the teachers just to see sort of if what they were saying we would also see enacted in their classes. And so that was also surprising, and they didn't even realize it, that they were using all these different suites of tools in a single lesson to meet their goal and objective. And maybe they were just doing it because we were there, but the people that we know them pretty well, this seemed to be something that they would do whether we were there or not. And they also are being very purposeful. Rather than select like a single tool, like the graphing calculator, I'm going to use that every day for the whole year, they're picking particular technology tools for specific goals. And so it wouldn't be uncommon for them to use Desmos for one thing and this app for something else. And so it's really customizing the tools for the particular goals that they have for their lesson. We also found that they wanted to know how the tools would support not just the mathematical learning, but how students would be collaborating or exploring or getting feedback and being able to communicate with one another. And as I mentioned, they would typically use a variety of tools for different purposes, and again, sometimes within the same lesson. So as I mentioned, back in 2005, we developed these materials for preparing teachers to use technology, where we're using software that they had to purchase. And so based on the feedback we got, we're like, we've got to go to free tools, right? If we're making them buy software, we know they're not using it in the schools. So we had to then revise sort of our materials to go to the free software that's available, that didn't have user logins, that could work across different platforms. So we are in the process of making some updates to the materials we created a while ago. That you can find those at the place at the Friday Institute at ncsu.edu. There's a username and password that you can also, I think it'll work to get you there. But I can show you what that place looks like. Let's see, here it is. So when you go to the Friday Institute, oops. I guess I logged into, okay, so here's what it looks like. So we have our online professional learning for educators here. We have a bunch of Moocs for teachers that are free. We tend to, and they keep building more of them. But in terms of mathematics, we have the teaching statistics through inferential reasoning, and many of the activities we have on the Mooc came from the PTMT materials, but now we're making sure to use small applets or the free CodeApp software teachers can access to no matter where they are. We also have a Teaching Math with Technology Mooc that is based on the ways we use technology throughout those units, and I'll say a little bit more about that And then we have teaching statistics through data investigations that takes the TSIR and goes a little bit further. So those are some, and then we also have for elementary teachers fraction foundations that talks about how to teach fractions in the elementary school. So those Moocs are available to teachers across the nation and world. We also have, here's the PTMT materials, and then Holly Lynn Lee has been working on the STEAM materials for statistics that are available as well. So within these materials that we've developed, as I mentioned, we have the data analysis and probability materials, the algebra and the geometry, and we're using the technology to help prepare teachers. We also have, from the study that we did, when we were collecting data, we asked their permission that if we record this and include it for pre-service teachers to see how practicing teachers are using technology. So we were trying to do two things at once, get our data, but then also create these videos for pre-service teachers. More voices of our teachers can be found here in Voices from the Field. So that's where you can find the materials in our units. Then we also, as I mentioned, have been, let's see, so we started creating those in 2005. We've had over 330 faculty who have used the materials across different places, and we've been getting graduate students at NC State involved in doing research around them as well. Within the portal that I just showed you, we've had over 778 users go to the PTMT portal with over 6,000, we imagine over 6,000 pre-service and in-service teachers, both through the portal as well as taking the Moocs. So we think that we're trying to broaden the reach of the materials beyond what we're doing at our single institution. So as I mentioned, we also had a Mooc that we developed. So the challenge with the Mooc, I don't know, has anybody taken a Mooc or tried teaching a Mooc? Oh my goodness, right? They're huge. You have all these people. They can do whatever they want. They can come when they want. They can leave when they want. And so trying to think about that as a teacher poses some real challenges. And the other issue was, I want to think about how I can prepare teachers to use technology when we know the technology is going to change. And in fact, the teachers who I interviewed, they were talking about technology that didn't exist, 5, 6, 7 years ago. So how do I help prepare teachers for things that don't yet exist? But we want sort of these general principles or guidelines that can help sort of guide their thinking. And so I developed sort of a framework to think about the use of technology that goes beyond the specifics of a particular tool by talking about, well, when you look at technology, how is it interacting with mathematics, right? So is there some things that happen with the technology that's not really faithful to the mathematics, right? So this idea of graphing something and you see the vertical asymptote, right? Or if you're dividing by 0 and something crazy happens. So we know that when you're using particular tools, sometimes what you see isn't exactly what it should happen, right? We can find these little glitches. And so you have to know, is that because of the technology or is that because of the math? So that's an important thing for teachers to be aware of. There's also the idea of when I use technology, am I using it just to amplify what I could do by paper and pencil more quickly, more efficiently, or is it changing the way I think about these ideas? So we talk about Roy P's idea of amplifier versus reorganizer. And then the idea of representations. So when I look at a tool, what are the different representations that I have available to think about the mathematics? I also think about the relationship between the technology and the teacher. So the technology I'm using, is it just for conveying material, kind of like a Google Doc or a PowerPoint slide, or is it used to do mathematical actions? And so as I'm using a technology, I might have that distinction in my mind. And what's the learning curve? And that came from our teachers as well. You don't want to use something if it's going to take a lot of time to learn. And then also, what's the interaction that is coming with, that students are experiencing? How are they interacting with the technology? Is it just like a movie that they're watching, or are they actually interacting? And what's the sort of feedback that they're receiving as a result? So those are just sort of broad questions you can ask about any tool. Doesn't matter what it might be, that might help your decision making in terms of whether you're going to use it. And then the other piece, which you can't read, is thinking about how technology might impact the pedagogical practices that we do in the classroom. So when technology comes into the classroom, how does it influence the types of tasks I might ask, right? And so in the Mooc, I had some conversations with Tom Dick, and he said it really boils down to this one thing. When I look at a tool, I say, what questions does this allow me to ask that maybe I couldn't ask without it? And I think that's a really good way to think about it. I also had a conversation with Dan Meyer. I caught up with him at a conference in Greensboro a couple years ago. He's super tall, by the way. But anyway, he also talked about, he wants to know more about what is this tool going to allow me to do, rather than thinking about, that's central to his thinking about whether he's going to use it or not. Also thinking about how technology can support discourse. So I love Desmos and the feature that when you have students using it, you can see at one time all the things that are on their screens, and then carefully select what you want to talk about as a class. It's a really nice feature of that tool. And then also thinking about how technology can support assessment. So I take these general pedagogical activities and think about what they look like when you bring in technology. So that's just sort of an overview of the Mooc framework that we created there. So my last project that we're working on right now, I mentioned, is using web Sketchpad. So I can just show you a quick preview of that. And the idea was to, again, we're trying to go to these free tools because we know that teachers won't use it if it's not free. And so we have a series of activities here, all that use web Sketchpad. And so students can, I might want to show you one. Let's see. Okay. So we used to do Dyna Graphs for a while using Geometry Sketchpad. Dyna Graph is just a graph of a function where you can think about your input and your output rather than being on those perpendicular axes, being on horizontal axes. And just by looking at it, you can't really tell what type of function you might have. But when I drag it, you can see that as A is changing, the output is changing. And so it forces students to reason about a function by thinking about rates of change in a dynamic way, rather than just looking at sort of what it might look like on a Cartesian axis. Okay, so I'll play these and we can talk about what they are, because I know you're already thinking about what type of function. So there's B. Any guesses what that is? Y equals X, right? That's a nice one. That's an easy one. All right, what about this one? This is a fun one. Kids love this. Kind of hop along, probably step function, greatest integer function, something like that. This one? So you can see the rate of change is pretty quick. So the output always positive. Maybe it's absolute value, maybe it's quadratic, right? So then they have to think about the difference between how an absolute value function would behave versus a quadratic. What about that first one? What are your thoughts on this? Think it's a cubic? So we can look at some of the, so here when it's, this point, by the way, is 0. That would be helpful. So this is 0 and this is 0. So I know that 0, 0 is a point, and then I can drag it. And you can kind of, if you want, you can add vertices as well. I'll let you think about that. So then we have other ones, and students reason about these functions using this different type of representation. It requires interaction and has them think differently about the tech. Ooh, that's a cool one. Has them think differently about the mathematics than they might otherwise. All right, that's our Forging Connections project. I left a little bit of time for questions, so but we have come to the end of what I had prepared to talk about. And I should acknowledge again all the work that I have had with my colleagues. So with the web Sketchpad that I'm working with, I'm collaborating with Daniel Scher and Scott Steckaty, who are in New York and Philadelphia. And we're part of the Sketchpad development tool, as well as Allison McCullough helping me with that. All right, so I'm going to stop there. I've been talking a long time. Any questions or discussion? Or comments? Yes?
So it looks like you were basically gleaning from the teachers the way they approached the process, but did any of them provide you with a framework like TPAC or some of the others that they use in the way they think through their work, or did you approach this with any particular framework in the background of your thinking?
Yeah, so the framework, they didn't bring any frameworks to us. They just talked about how they used it. The framework we brought was thinking about internal and external factors, the types of technology they might be using, and the purposes, why they might be using it. And the way that the technology might be positioned in the classroom between the teachers and students. So we were trying to just learn from them. Yeah, but that's a good question. Any other questions? Yeah.
Maybe you said it, but how were the teachers selected? How did they volunteer? Did you just ask?
Oh, yeah. So we've been working with lots of teachers over the years, and so we sent out an email invitation with the caveat that they had to meet with us either through Zoom, so some of our interviews were through Zoom, or they could come to NC State, and we had the pretty black background that we used when we interviewed them. So as long as they agreed to participate in that interview, then they were included in the study. Yeah. But we started with a much larger list than 21, but we got 21 who agreed. Other questions? Yeah, Travis?
Were they coming from all different teacher education programs at different universities, or were they all your graduates?
Yeah, so IRB won't let me tell you that, but they are from a southeast university in the southeast.
So are there ways that you can then look at kind of, are there shifts that you'd want to make in your teacher preparation programs based on the responses that you're hearing from them?
Yeah, absolutely.
And what are some of the ways that you've designed your program at NC State based on some of the things you've learned?
Right, so I think, the way technology has been used over the years has shifted a lot, I think, as well, right? So I can remember when I first had the graphing calculator, I spent a lot of time telling them how to press buttons, right? And now you still have to teach them how to use the graphing calculator, but I focus more on the questions that I'm going to ask them rather than what they're going to produce. So I think similarly with our materials, we spent a lot of time with them learning how to use Fathom, right? So how do you create a scatter plot, and how do you create your bins, and so all the sort of technology pieces, and we've discovered that seems to be less interesting. It's better to maybe give them something already set up so that then they can start with the statistical exploration. So I think what we're doing is we're creating for them more of the things that already are created for them. Because if we don't create them, then we also know they go out and they find them, because they just don't have time to create things from scratch. And if they have to create it from scratch, they probably won't use it. So I think that's one thing that's changed in our program, is instead of going through the nitty-gritty of specific programs and how to use them, it's more about the mathematics and the questions and that sort of thing. Yes?
So you had mentioned, and we all know, that a single technology course, like how to use technology, isn't really all that effective. Do you all have ways of integrating some of this into their other coursework, like you're in the College of Ed?
Yeah.
So in their mathematics coursework, is
Yeah.
there any kind of cross-talk?
Yeah. Yeah, so I worked a few years ago with a mathematician in the math department on the college geometry class. So in the college geometry class, it was typically, it's mostly non-Euclidean, but we brought in the program non-Euclid so they could explore hyperbolic geometry using the technology. We did some taxicab geometry using Sketchpad. So we've incorporated the dynamic geometry in the college geometry class, which I'm super excited about. In the calculus, they used to use Mathematica. I don't know if they still do, or if they're using, I don't know what they're using, to be honest. And the statistics, I think the statistics department, Holly Lynn has been collaborating with to use some applets and other things. Yeah, but you're absolutely right. We can't just do it in the College of Ed. They need to experience it outside.
I was just
Yeah.
wondering, like, how much buy-in you're getting from,
Yeah.
you know, to let them experience the technology as math learners, and then to be able to come in.
Yeah, they're pretty open to that. We're not getting resistance. Like at other universities, sometimes there is resistance to that. Other questions?
What do you feel is the next big thing with technology that you'd like to see?
Oh, man. I don't know. That's a good question. I'd love to see it better integrated with textbooks, right? So if we think about, where textbooks are is a whole different issue, right? So many kids don't even have books. But if they could create books that have the technology integrated within it, I think that would be super, super cool. Because I think the other issue is you go to so many different places. If it all could be in one place, that might be nice. I don't know. Good question. Yeah.
I might ask you another question actually based off that. So,
yeah.
You know, one of the things you kind of often run into, and you'd mentioned this idea that you want to somehow divorce it from any one specific technology, but there are 1,000 books out there that are teaching calculus using MATLAB or Maple or da-da-da. Do you have a thought on how could one write such a textbook that focuses on the technology or uses of technology without focusing on a particular technology?
I don't know. Yeah. So the other issue is the higher level you get into the math, the more specific tools that you need, right? So could you just do one for computer algebra systems, right? And I think there was some books for calculus with CAS, but maybe they used Derive or the 92 a while ago, or Mathematica. Because at some point you do need to know the specific ways to input, right? Or else you're not going to get any answers. I'd have to think about that. I don't know. But could you have sort of an e-textbook that's calculus based, and that when you get to that page you have the input screen right there, and maybe there's cues, right, about how, like little help menus, just in time information that you could use. I don't know. Other questions?
Let's thank our speakers.
Thank you.